Okay, this is Algebra 2, Lesson 15. We're going to talk about elimination. In our last lesson, we talked about doing, a couple lessons ago, we did substitution method to find the solution of two linear equations. We called them systems of linear equations. And now we're going to learn a different way called elimination, or basically we're adding two equations together. So let's look at this. If we said, if we had this equation, x plus 2 equals 7. We said we can use the addition rule to get rid of the 2. We add negative 2 to both sides, and we get x equals 5. Okay, we can use a similar process when we're adding two systems of linear equations, which is what this is. So we have 2x plus y equals 11, and 3x minus 2y equals 6. We can kind of do the same thing. So let's look at 2x. Excuse me. You can read this. 2x plus y equals 11, and 3x minus 2y equals 6. Now, if I multiply this equation by 2, I can do that. It doesn't change as long as I multiply every term in the entire equation. So if I'm going to multiply this by 2 and this by 1, this becomes times, we use a distributive property, times every term. 2 times 2x, it simply becomes what? 4x plus 2y equals 2. Do you see that? It's 2 times every term. Here, multiply by 1, so it doesn't change. It's simply the same. 3x minus 2y equals 6. Try and get that glare out. Making it worse. Okay. So basically, what I have here, I can add these two equations. I line up like terms because we have to add like terms. This is a 2 positive 2y. And this is a negative 2y. So they're what? Opposites. And opposites, we said, the sum of two opposites is always 0. So they cancel out. Here you have two like terms. You have a positive 4 and a positive 3, which gives you 7x equals 6 plus 2 is 8. Now I'm down to one variable. I can solve for x. I divide both sides by 7, and I simply get, I'm sorry, this is 22. I must have wrote the problem down because this is 11. Okay, so this becomes 28 divided by 7, so x is equal to 4. You see that? So now I can go back and solve for y. How do I solve for y? I put this into one of my two original equations up here, just like you did on substitution. So I'm going to put it in, I don't know, let's put it in this one. So 2 times 4 plus y equals 11. So it's 8 plus y equals 11 minus 8 minus 8. Y is equal to 3. So my solution to this is xy, or simply 4, 3, to these systems of linear equations. And then how do I check it? I put 3 and 4 in this equation. I put 3 and 4 in that. So we already kind of checked this one. Let's try this one. So we're going to have 3. I'm messing up here. 3 times 4 minus 2 times y is 3 equals 6. So we have 12 minus 6 equals 6. And does 6 equal 6? Yes, it does. So that solution works for both of them. That's all elimination is. So let's do another problem. Let's do 15.1. So basically, you have to get either the x or y to be opposites. So if they're not already like that, then you have to figure out what you need to multiply one or both equations by to equal that. So let's look at this. 3x plus 2y equals 23, and negative 2x plus 3y equals 2. Okay, we have no terms that are opposite, do we? Sometimes you just have to multiply one of the equations by a number, but it looks like we're going to have to multiply two. So basically what you're getting is a common denominator between 2 and 3. Even though they're coefficients, we pretend like they're in the denominator. How do you get a common denominator? So what's a common denominator? Here I have opposite signs, so if I just got the common denominator, I don't have to multiply by a negative. And you don't want to multiply by negatives. You can, but they're kind of tricky because you have to distribute that negative through every single term, and you're more likely to make a mistake. These two are the same numbers, just flipped, but they're the same sign. So one of them I'd have to multiply by a negative. So I'm going to go with this first term, and I see I can multiply this by 2 and this by 3, and I'm going to write it down here. And it's best to write it that way, but I don't have as much space, and it's just easier for me right now to do it this way. So 2 times 3x is going to give me 6x, plus 2 times 2y is 4y. 2 times 23 is 46. Now I'm going to do the next one. 3 times negative 2 is negative 6x. 3 times 3y is 9y equals 6. Now do you see I have opposites? Now I could have done the same thing here, flipped them to and gotten 6 here, but then I'd have to multiply one of these by a negative because they're both positive. And this way I didn't have to multiply either one of my equations by a negative. So make sure the like terms are lined up. So now these equal 0, so I'm left with 13y, because remember, how do we add terms? They have to be like terms, add the coefficients, and this is 52. Divide both sides by 13, yes, and we get y equals 4. Okay, so how do we go back and check it? Well, before we check it or get x, your code for this lesson is you need to put the initials PJ at the right-hand corner of homework lesson number 13. Okay? The initials PJ, the right-hand corner of lesson 13. Okay? I'm erasing it now. It's not on there. You lose 50 points off your homework grade. So automatically you start off with a 50. Can't get any higher than that if you make 100 on it. Alright, so now to get x, we substitute 4 into either one of these equations. This one has a negative, and I don't like to work with negatives, but you can, it doesn't matter. I'm going to put it in the first one. Or actually, let's go ahead and put it in the second one. So basically, I'm going to say negative 2x plus 3 times 4 equals 2. Negative 2x plus 12 equals 2. I'm going to minus 12 for both sides. I'm just simply using algebra. This is a minus 12. So this cancels out. Negative 2x equals a negative 10. Divide both sides by a negative 2. And I get x equals 5. Okay, so my solution is 5, 4. Because remember, you put in an x, y coordinate. So how do I check it? I need to check it into the other equation to make sure it works. So that equation is 3 times 5 plus 2 times 4 should equal to 23. Let's see, 15 plus 8 equals 23, and 23 equals 23. So it works. So that is the solution. And you would also go back and double check to make sure you didn't do bad math somewhere, which you could have when solving for 5. Put them both back in here, and they should be equal to 2. This should be equal to 2 when you put these numbers in. If it doesn't, you did some bad math somewhere, you need to go back and redo your equation. That is it. Do all practice problems. There's just one, and it says use elimination. Elimination means you add them together. We'll see you in class.